Okay, so here's P, Q, R, and S. Okay. This is the x-axis. Okay. So the first midpoint, I think visually you can see this. Let's call this M1. This is clearly negative 1 and 1. That's the first midpoint. Here too you can see it. This is going to be 5, 6, 7, and 1. It's these two, it's not as easy to see. So this is P, Q, R, S. So what's the midpoint between Q and R? So it's going to be 6 over 2 and 7 over 2. So that's 3. This is 3 and 7 over 2. And P and S is going to be minus 2 plus 8 over 2. Right, minus 2 plus 8 over 2. And minus 1, minus 1, minus 1, minus 2, and minus 1 over 2. So 6 over 2 is 3. This is minus 3 over 2. Right, so 3 and minus 3 over 2. So we have to show that this is a rhombus, which means these lengths are all equal. Okay, so let's call this M1, M2, M3, and M4. The distance of M1 to M2. So it's delta x squared plus delta y squared. The change in the x, right, is 3, subtract negative 1, that's 4. 7 over 2 minus 1 is 5 over 2 squared. Okay, so just leave it like that. We're going to be able to compare the size of numbers just by looking at the form. Let's check now M2 to M3. 7 minus 3, which is 4. And 1 minus, that is minus 5 over 2. So clearly you can see they're going to equal. M3 to M4. Right, 3 minus 7 is minus 4 squared. Right, minus 5 over 2 squared. Lastly, it's just going to be negative 1, negative 3. That's again negative 4 squared. 1 minus this is going to be a positive 5 over 2 squared. So clearly they're all same, and that proves that it's a rhombus.